Have you ever just stopped and thought about how incredible it is? You type a question, any question, into an AI, and boom, in seconds, you get a nearly perfect answer. It feels like straight up magic. But what's happening behind the scenes, behind that curtain, is honestly even more amazing. Today, we're gonna pull that curtain back and unpack the whole process step by step.
So, what is actually going on inside that digital black box? You know, in that tiny gap between you hitting enter and the answer just appearing on your screen? That's the big mystery we are going to solve together today.
You know, when you really boil it down, the journey your prompt takes is basically a three-step dance. First, the AI has to understand the words you typed, not just the dictionary definition, but what you meant. Then it processes that meaning, connecting it to everything it knows. And finally, it cooks up a brand new response just for you. We're gonna follow this whole journey, so let's start right at the beginning, how it understands your words. All right, our first stop is maybe the biggest hurdle in all of artificial intelligence. How do you get a machine to understand human language? I mean, think about it. Computers don't speak English, they speak math. So how in the world do you build a bridge between our messy, nuanced words and their cold, hard numbers? How does a machine actually learn to read? It all kicks off with a process called tokenization. Before an AI can even begin to understand a sentence, it has to chop it up into its smallest meaningful bits, or tokens. And this is way smarter than just splitting a sentence at the spaces. For example, if it sees the word glitters, a good tokenizer will actually break that into two pieces, the root word, glitter, and the suffix, s. This is so important because it helps the AI immediately see that glitter and glitters are basically the same idea, just with a little grammatical twist. So, once everything is broken into tokens, the AI needs to figure out what they all mean, and it does this by turning each token into something called a vector, which is just a fancy word for a long string of numbers. You can imagine these numbers as coordinates on a giant, mind-bendingly complex map of meaning. On this map, words that mean similar things, like dog and puppy, are plotted right next to each other. But words like car or planet, they're way, way off in another part of the map. This incredible web of connections is how the machine starts to get the feel of our language. Now, this whole vector map system sounds pretty solid until you run into a very human problem: ambiguity. So many of our words have multiple meanings. Take the word apple. How does the AI know if we're talking about the fruit, the tech giant, or something else entirely? The word by itself is useless. It needs clues. And those clues are all about context. It's everything, right? If you say a tasty apple, the word tasty is a giant neon sign pointing to the fruit. But if you say Apple's new product, the word product makes it obvious you're talking about the company. The words around the target word are what give it its true meaning. And this leads us to a massive, massive breakthrough in AI called the attention mechanism. Before this idea came along, models kind of treated every word in a sentence as equally important. But attention works like a spotlight. For tasty apple, it shines that spotlight right on tasty, telling the model, hey, pay attention, this is the most important clue you're gonna get. This ability to dynamically weigh which words matter most in a sentence, it was an absolute game changer. Okay, so the AI can now read our prompts pretty intelligently. It gets the individual words, it understands the context. But how does it know what a tasty apple or a new product even is in the first place? Well, that knowledge has to come from its training. So let's peek inside the AI's brain and see how this machine actually learns. For the longest time, the only way to teach an AI was with something called supervised learning, and it was a slog. It meant teams of people had to sit there and manually label millions of examples by hand. It was slow, it was expensive, it was painful. The real revolution was self-supervised learning. Here, the AI basically teaches itself. You just give it a massive data set, like pretty much the entire internet, and it figures out how to create its own lessons. This is what made today's unbelievably powerful models possible. So how does it teach itself? It basically creates its own fill-in-the-blank puzzles. The AI will take a sentence from, say, a Wikipedia article or a book, hide one of the words, and then try to guess what word goes in the blank. Now, imagine it doing that billions and billions and billions of times. It's not just memorizing sentences, it's learning the deep, underlying patterns of grammar, logic, and how ideas connect in human language. Now, you've probably heard two terms thrown around a lot: transformer and LLM. This is the absolute easiest way to think about them. The transformer is the revolutionary piece of technology. It's the powerful engine inside. It's the architecture that uses things like that attention mechanism we talked about. The large language model, or LLM, is the whole car built around that engine. It's the finished product with all the training and the bells and whistles. The transformer is the invention. The LLM is what you get to drive. An LLM that's trained on the whole internet is a jack of all trades, but it's not really a master of any one thing. So what if you need a real specialist? That's where fine-tuning comes in. Think of it like this. The base model is a brilliant college grad. Fine-tuning is like sending that grad to medical school. You take the general model and put it through a second round of intense training on a very specific data set, like medical journals or legal documents, and you turn it from a generalist into a world-class expert. So we've got it, a model that understands language and has learned from a library bigger than any human could ever read. But there's a huge catch. That library is frozen in time. And AI's knowledge is only as current as the day its training stopped. So how do we connect it to the real world, which is changing every single second?
Yeah, just think about that. An AI's knowledge is locked in the past. It literally has no clue what happened yesterday, so it can be factually wrong about current events. Or, even worse, when it gets a question it doesn't know the answer to, it might just make something up. You've probably heard this called a hallucination, and it is a huge problem. We have to find a way to anchor the AI in today's reality. And the solution is really clever. It's a process called retrieval augmented generation, or RAG for short. Honestly, the best way to think about it is like giving the AI an open book test. When you ask a question, the system doesn't just pass it to the AI. First, it goes out and finds fresh, relevant documents, like today's news articles or your company's latest reports. Then, it bundles those documents together with your original question and gives that whole package to the AI. It's basically saying, okay, answer the question, but only use the facts I just gave you. This keeps the answer grounded in truth, not just old data. So there you have it. We've unpacked the black box, from how it understands our words, to how it learns, to how it generates answers that are actually factual. But where is all this amazing technology headed? Well, you might think the future is all about building bigger and bigger models, but the most exciting trend is actually the opposite. Things are getting smaller, faster, and a lot more personal. While the giant large language models get all the media attention, the real action for a lot of businesses is with small language models, or SLMs. And the difference, as you can see here, is just staggering. SLMs are way, way smaller, which makes them much, much cheaper and faster to run. And instead of training them on the entire public internet, you train them on your own specific private data. This lets you create a hyper-specialized expert that does one thing perfectly, like manage your company's customer support chats or analyze your internal financial data. And that's where this gets really exciting for all of us. Because as this tech gets smaller, more efficient, and easier to use, it's not just going to be for giant corporations. It's going to become a personal tool. So that leaves us with a really fun question to chew on. If you could build your own personal AI, trained on your life and your needs, what is the one single task you would want it to master for you?